Alright class, so today you're going to be talking about single replacement reactions. So far you did synthesis, which is just taking two reactants and taking them together to make a compound, and decomposition, which is the opposite, taking a compound and breaking that down into its elements, or smaller compounds. So single replacement is very simple. During this reaction, one element, which is usually a metal, will replace another in a compound. And you saw this very recently in the copper cycle lab, so I'm going to use that last reaction from the lab as an example. So you guys took copper 2 sulfate, that solution, that was your blue solution, and you put zinc in it. And then the zinc and the copper treated places, so the solution became zinc 2 sulfate and you were left with a solid copper, which is what you'd started with in the lab. So the reaction for that I have written here, and then the reactants I started down here with their symbols. We have a copper sulfate solution plus solid zinc, and then I'll do the products down below. So we get zinc 2 sulfate, no subscripts with the zinc or an additional one with the sulfate because the sulfate has a minus 2 charge. The zinc, since it's zinc 2, has a plus 2 charge. We just need one of each. And you can actually include here because we saw it, we know that happened, it was an aqueous solution. And we also ended up with solid copper. And that is the reaction. That's all there is to it. Basically, you're just going to be trading the metals. Okay? Couple things don't forget from last week. Hofbrinkel, this only applies when these elements are not in a compound. You only do it when they're alone. Like the zinc and the copper, those are considered alone right now. And a compound means it's with something else, another type of element. This rule does not apply in those cases, only singular. Reactions are balanced using coefficients. You can't balance using subscripts. And this is your last step. I did not do that up here in this example because it's already balanced.